You ever look at a giant skyscraper and just wonder what's actually holding that thing up? Or how a highway can take a pounding from millions of cars and not just crumble? Well, today we're going deep, literally, to explore the invisible, incredibly precise engineering that our entire world is built on.
All right, so think about this for a second. You've got a towering skyscraper, a massive vibrating pump in a factory, and the smooth highway you drive on every day. What on earth could those three things possibly have in common?
Well, it turns out they all depend on this hidden world of super specialized foundations and advanced materials. It's the stuff we almost never see, but our modern lives would literally fall apart without it.
Okay, so let's dig in, and we're going to start from the ground up, literally. We're talking about the unseen support system, and believe me, this is where engineers face some of their absolute biggest challenges. So here's the fundamental problem, right? You've got these incredible forces, the crushing weight of a building, the constant powerful vibrations from heavy machinery, and you need to put all of that on, well, on dirt. And the thing is, the soil right at the surface, it's often just way too weak to handle that kind of load. So what happens? Things start to sink, they crack, or worse, you get a catastrophic failure.
So, how in the world do you solve that? Well, the answer, a lot of the time, is something called pile foundations. The easiest way to think of them is like giant stilts for a building. They basically just bypass all that weak soil on the top and transfer all that weight, all those forces, way, way down to stronger, more stable layers of soil, or even solid bedrock deep underground. But just having these stilts in the ground is only part of the story. The real magic, the real genius of it, is how engineers tie everything together to build what they call a monolithic base. So, monolithic structure, what does that even mean? Well, the goal is to make every single piece of that foundation, the concrete, the steel, even the machine bolted to it, act like one single solid object. This is absolutely critical for anything that moves or vibrates, because a unified base can handle and absorb those forces way, way more effectively than a bunch of separate parts.
Okay, so how do you actually make that happen? How do you create that perfect monolithic connection? It all comes down to this little guy right here, the anchor bolt. Now, it might just look like a big screw, but trust me, this thing is a masterpiece of precision engineering. It's the critical link holding the equipment and the foundation together.
And the secret to how it works is something called stretch. You see, the bolt is put inside a sleeve, which leaves an empty space around it. This gives it room to literally stretch when you tighten it down, and we're talking a very specific amount, about 10 to 15 times its own diameter. This stretch lets it act like a super powerful spring, creating this immense clamping force that locks everything together as one solid unit.
All right, so we've got the deep foundation, we've got the anchor bolts doing their thing, but there's still a tiny, tiny gap between the machine's steel base and the concrete foundation. And that's where the next crucial piece of this puzzle comes in, the power of grout.
And listen, grout is so much more than just some goop you use to fill a hole. It's the critical material that creates that final, perfect, solid connection we've been talking about. Its job is to bond the steel to the concrete and transfer every single vibration, every force, from that machine down into the massive foundation below. Now, I want you to just look at this number for a second. 30. 30. 30 times. What on earth do you think that represents?
This is going to blow your mind. That's how much better a special epoxy grout is at damping or absorbing vibration than solid steel. Not 30% better, 30 times better. It's incredible.
And just look at this chart, it really puts it in perspective. If we say steel has a vibration damping value of 1, right? Concrete is already about 8 times better, which is pretty good. But then you look at epoxy grout, it's just off the charts at 30 times better. Why? Well, it's all about its complex polymer structure, which is just fantastic at taking that vibrational energy and turning it into tiny, harmless amounts of heat. It's an absolute game changer for creating a super stable foundation. But here's the catch. For that amazing epoxy grout to work its magic, it needs a perfect, unbreakable bond with the concrete. And getting that bond requires some seriously intense prep work. I mean, they literally chip away the top layer of the concrete until it's super rough, with at least half of the little stones inside, the aggregate, fractured and exposed. This creates a huge, jagged surface area for the grout to lock onto. If you get this step wrong, the whole system could fail. So we've gone deep underground to see this incredible hidden engineering. But you know what?
This world is also right under our tires every single day. So now we're going to shift gears and look at the sticky solution that literally paves our world. Yep, you guessed it. We're talking about asphalt. And the secret ingredient, the black, sticky glue that holds it all together, is a material called bitumen. And don't think for a second this is just some leftover gunk from making gasoline. Bitumen is a highly, highly engineered material. It starts out as the heaviest stuff left over after refining crude oil, sure. But then it goes through this whole complex process. It's purified, it's heated, it's even blown with hot air to make it tougher. And for high-stress roads, they even add special polymers to it to get just the right amount of durability and flexibility. It's a real science.
And just like every other component we've talked about, every batch of bitumen goes through a whole battery of tests. Engineers are constantly measuring things like its hardness, how well it resists heat, how flexible it is, how it flows. Every single property is precisely controlled to match exactly what's needed for the job, whether it's a quiet little side street or a massive interstate highway.
So let's step back for a second. What does this all add up to? Let's bring it all together and see how these pieces engineer our modern world. I mean, think about the journey we've been on. We've gone from deep, deep underground with those pile foundations, all the way to the microscopic level of epoxy grout bonding to concrete. We've seen how every single element, no matter how small, is meticulously designed and installed to work together as one single, powerful system.
There's actually a quote from the American Petroleum Institute that just nails it perfectly. It says, "The primary goal of an effective foundation system is to create a monolithic structure where the individual components are interconnected and act as a single structure." That right there, that is the secret sauce to building things that are meant to last. So, at the end of the day, what's the big takeaway here? It's that our world, from the deepest piles buried in the earth to the engineered blacktop at our roads, is quite literally built on a foundation of hidden precision. It's just incredible when you think about it. Which kind of leaves us with one final thought. The next time you're driving over a bridge or you look up at a massive skyscraper, I hope you'll think about all that unseen engineering holding it together. The science of stretch and the bolts, the amazing power of the grout, and the refined chemistry of the asphalt. It's all there, working perfectly, just out of sight.